Good afternoon to everyone. I am Lani B. Laureano, a DIT student of Technological Institute of the Philippines. Let me present to you our paper entitled Affinity Propagation SMOTE, Synthetic Minority Oversampling Technique Approach for Imbalanced Dataset Used in Predicting Student at Risk of Low Performance. Data mining is one of the breakthroughs in discovering knowledge from analysis of large volumes of dataset. It is applied in different areas like business, medicine, agriculture, engineering, economy, and even in education. In education, data mining is termed as educational data mining, which aims to improve the quality of education by exploring educational data sets. Applications of educational data mining includes predicting student performance, clustering analysis, and discovering domain models, to name a few. In the application of prediction, it is the assumption that there is an equal distribution between the classes. However, in the real scenario, imbalanced data exists. This happens when one of the classes is underrepresented in the whole dataset, just like what is shown in this diagram. This imbalance can cause misclassification of instances in the prediction phase. Thus, the need for balancing it is very important. There are several approaches in handling imbalanced data. This includes data level preprocessing and algorithm-based. One of the most known approaches in the processing is synthetic minority oversampling technique, or called the SMOTE. This generates synthetic samples between minority samples and its neighbors, as shown in the figure. So this is the majority sample, and this is the minority sample. The synthetic samples are created in between the minority samples. However, SMOTE has downside in creating noisy samples between the oversamples because it creates synthetic data regardless of position in the feature space. Thus, modification and extension have been introduced, including Affinity Propagation SMOTE. Affinity Propagation SMOTE uses affinity propagation to cluster automatically the datasets, and the clusters produced are filtered to determine which clusters are to be used for oversampling. It has three main steps. The first one is clustering using affinity propagation. This generates the clusters and cluster exemplars. The second step is to filter the cluster by choosing the clusters with 50% of the minority instances for the generation of the synthetic data. And the last one is the oversampling step, which uses the exemplar as the basis of synthetic data generation. The oversampling is still based on synthetic minority oversampling, which generates samples among the neighborhood. This figure shows the research process followed by this study. Available data from a public institution is used in processes such as preprocessing, classification, and evaluation were done. The details will be discussed in the next slides. So the dataset is a performance of 2,112 freshman students of Davao Oriental State College of Science and Technology. The respective data is admission data and high school, general average, and also the DOSCST results, or State College Aptitude and Scholarship Test results. It has 10 variables. The class is categorized in good performance and low performance. The imbalance ratio is 17.8. The imbalance data undergoes the preprocessing, in which synthetic minority oversampling technique and affinity propagation synthetic minority oversampling technique are used for the generation of synthetic data needed for the balanced dataset. After the application of SMOTE and affinity propagation SMOTE, the balanced datasets produced are used for the classification. The classifiers used are J48 and Naïve Bayes implemented using the WECA software. For the evaluation, we have the recall, precision, F-measure, G-mean, and area under the curve as our performance evaluators. For the results and discussion, as shown in Table 1, we have here the results for the SMOTE, and we have here for the Affinity Propagation SMOTE in terms of accuracy, precision, recall of the classifiers. As you can see here, the percentage lead of Affinity Propagation SMOTE to SMOTE in terms of accuracy, precision, and recall using the J48 classifier is 0.56%, 0.60%, and for the recall, it's 0.60%. While for the Naïve Bayes, it is 3.32%, 4.60%, and 3.30%. On Table 2, this is a performance comparison in terms of F-measure, G-mean, and area under the curve. As we see here, the percentage lead of AP SMOTE for J48 is 0.60%, for G-mean, it's 8.88%, and for the area under the curve is 1.2%. For the Naïve Bayes, it's 3.2%, 6.58%, and 3.30% for F-measure, G-mean, and AUC. With these results, for this educational dataset used, the imbalanced data applied with Affinity Propagation SMOTE has improved the performance of J48 and Naïve Bayes classifiers, thus improves the prediction of student at risk of low performance. For the conclusion, the imbalanced dataset in predicting student performance is handled through Affinity Propagation SMOTE, based on the performance comparison of classifiers in terms of accuracy, recall, precision, F-measure, and G-mean, and also the area under the curve. The dataset applied with Affinity Propagation SMOTE shows better performance for Naïve Bayes and J48 classifiers. With this, the prediction of student at risk of low performance is improved. With it, early interventions can be given by the administration. For future works, imbalanced data is still an interesting area in the data mining field. So for the future studies, the exploration of using Affinity Propagation SMOTE for multi-class dataset could be done. So that would be all. Thank you. Maraming salamat po.